Hi, this is Ashley Delaney from Heartland AEA. I'm a science consultant. Here are some demonstrations of the activities we weren't able to get to at Hello Iowa. Keep in mind, at the link below, you can go and get any of the lesson plans from our Heartland AEA Science Consultant website. So on our segment, we demonstrated how high pressure air will stay on top of low pressure air, or warm liquid will actually rise and cool liquid will sink. The same is true for warm and cool air. Cool air will sink because it's more dense, and warm air will rise because it is less dense. So you can think about density being how many particles are pressed together in a certain area. So when we look at air, for an example, we can do that by demonstrating soap film on a bottle. So you can see we just have a little bit of soap film, just like you would blowing bubbles. We're going to dip that into some soapy water, and you can put that in the cold water, and the soap bubble will actually suck into the bottle because the particles are pressed close together. Remember, high pressure is when they are pressed close together. So it's great for preschools to demonstrate this by dancing under high pressure. So you can have kids put their arms and legs close together and they have to move under high pressure. We do the same thing when we're cold. We press everything together, right? So that is high pressure relates to cool air. The same thing is opposite for warm air. So if we put our soap bubble, our soap film, our bottle with soap film, again is here, and we put it in the warm water, you can see that the high pressure, or the particles are moving around in a lot of space, causes the bubble to blow up instead of suck in because we have more space and moving around. Same thing with preschoolers. You can go ahead and put this back in the cold water, and that air bubble will go ahead and suck right back into the bottle like it did previously with the cold water. But kids can dance under high pressure, which we did with the cold water, but they can also dance under low pressure, which means they don't have to keep their arms and legs together. Instead, they can free move, and that's what happens with warm air. The particles are not under a lot of pressure, so it's a low pressure system. So when we put these things together, it allows kids to see how clouds are made. So we've already talked about how large masses mix together, right? If we have a high pressure and a low pressure system, that high pressure wants to go up, the low pressure wants to go down. Oh, I'm sorry, opposite. Low pressure wants to go up, which is our warm air, and high pressure wants to go down, which is our cool air. So if we take our warm water, remember we need that evaporation, which we talked about on Hello Iowa. We can add that into our bottle, shake it around, give ourselves some evaporation. But the last final ingredient we need for a cloud, we talked about water vapor, we've talked about a change in temperature and pressure. The last thing that we need is going to be dust particles. So clouds are actually really dirty. Those water molecules that are formed in the air from all of that evaporation need something to grasp onto to create those raindrops or those pieces of snow. So if we just have, warm and cold water and we have a change in pressure, we're not really creating a cloud. You might see some condensation on the sides, but we're not creating a cloud with that change in pressure. When we add in some dust particles using smoke from a match, we're just going to let this drop in for a second, and it's going to add some of those dust particles we need. Then, when you squeeze the water bottle, you're creating that high pressure system, and when we release it, it's going to be a low pressure system. It's going to create a cloud in a bottle. Now, if we go back to high pressure, it's going to make our cloud disappear. Now, kids can do this over and over again, and you can add a little bit more hot water into the bottle, and it's a great toy for kids to play with. Awesome experiment to do at home with homeschool. Also a great thing that we can do at preschool centers and child care centers because it is really safe for kids to play with. Make sure the adult is doing the match. We can also do the same thing on a greater scale with a larger bottle and a tire pump. So in here, I've already added some hot water and I've already added some dust particles in there from a match a little bit ago before I started filming. And I'm just gonna go ahead and increase the pressure inside this bottle by pumping the bicycle pump into this larger bottle. And I will give some directions on how to create this in those lessons plans at heartlandaea.org. But once I've added a lot of pressure into my bottle, I can go ahead and pull my cork and have a change in pressure and a little cloud will pop out of the top. But if I add a lot of pressure, so I just did about 10 pumps there, I'm this time going to add in about 15 pumps, so it's a very, very high pressure system. And we have that dramatic drop in pressure that you often feel with a larger storm, like a thunderstorm. That's why we use those plastic bins. It keeps everything nice and clean when we're working in science. So now we're creating a really, really high pressure system. If we let go of our cork, it's going to create a large cloud, just like you would see in a thunderstorm or some of our more severe weather storms. So I highly encourage you to go ahead and choose some science experiments that are related to kids' daily lives. Make sure that they connect with those kids. Let kids play with science. Let them ask questions and then work diligently to capitalize on that curiosity. Thank you for joining me. And if you have any questions or we can help at all at Heartland AEA, please go to the link provided. Thank you so much.